afternoon, good morning to me. I'm also, like Matt, in the US and excited to be talking to you about a new topic that I haven't talked about too much before in presentations. I usually talk about just pure MoveIt functionality and the roadmap. I believe there's a talk tomorrow from my colleague Henning at this event that'll get more into the technical updates on MoveIt 2, maybe even talk about MoveIt 3 a little bit, but I'm going to stay a little more high level and talk about some of the recent developments and past developments of ROS in space and how robot arms are playing a part in that, how PickNik's starting to play a part in that as well. Yeah, I'm going to go also about some of the business cases. I was told that today's session a little more on the business commercial side, so I'll talk about how is this relevant to industrial applications. The short of it is basically that there's now a desire for manufacturing in space. So that'll tie back in the ROS Industrial side of this conversation of making goods and services of a higher quality because of a low gravity environment. A little bit about me. I have a PhD in robot motion planning. I've kind of been the MoveIt guy for a long time. Although PickNik Robotics that I lead is now a team of about 35 people who know MoveIt and motion planning pretty well, and we've worked with 60 customers to date, helping them best use MoveIt. So we've got a lot of experts on our team, and we've been around since 2015. So we continue to work with all sorts of different industries, not just space. It's been really wild. So I'll get to that in a second. And we are in Boulder, Colorado, which is kind of in the very center of the U.S. in the mountains there. And it's an honor to be speaking at this event again. I always enjoy to see what's the latest happening in ROS Industrial. And so our flagship product, if you will, is MoveIt. I'm not sure if product's the right word. It is an open source platform that originated with the whole ROS ecosystem at Willow Garage back in 2010. You see here it's been through a couple iterations, and we're now gearing up for what we might call MoveIt 3. Again, more updates on that tomorrow. But basically it helps you motion plan 1 or 2 robot arms. It can even now synchronize with mobile bases and generate paths from point A to B. A lot of similar functionality to Tesseract. This one focuses a little bit less on surface deconstruction and planning over surfaces, but we're now bringing it to a lot more general applications. So some of the projects we've been really focused on is outdoor harvesting. So you can imagine a tractor with robot arms hanging off of it and doing manipulation in farms is one of our exciting projects. We've done a handful of kitchen robotics helping with ghost kitchens or consumer in your home kitchens. How can robot arms augment humans and help us in our everyday lives? And of course, traditional logistics type things like bin picking, depalletizing, palletizing, removing things on and off conveyor belts. So that's kind of the bread and butter that we're familiar with, the terrestrial applications that get spoken about a lot in the ROS Industrial Consortium. One thing that we are really proud of is that all but one of our customers has now ported everything to ROS2. So we're becoming quite the ROS2 shop in the past year ourselves, except for this one larger legacy project that we still hope to get over soon, but there's always constraints in when and how you can do that. In the past year or so, we've also had a couple of underwater robotics programs with 2 robot arms being synchronized, and this is a little closer to the space application. You have these underwater currents that you're having to station keep to counteract. You have lower bandwidth often when you're not tethered because communication through water is more difficult, dealing with sonar sensors. And so this has been pushing us to think about the problem of a human in the loop commanding things, but maybe not teleop because of latency and frustrations with trying to teleop robot arms. That the user interface is not as intuitive. So that's been a big learning point for us recently. And now, which is the subject of this talk, is where do robot arms in particular, but also robots in general, find their place in space? Of course, there's been robotics in space for a long time, since the beginning of the space program. Satellites are really just robotic vehicles, but I'll mostly talk about robot arms themselves. And so we've seen robot arms successfully on the space shuttle program with the Canadarm2. A number of the Mars rovers have had arms on them for taking soil samples, like the current Perseverance. But in terms of beyond that, we're really interested in the inter-vehicle robotics problem. In 2011, NASA did launch a fully humanoid robot called the Robonaut 2, and it runs ROS at the high-level application level. But that program's had some setbacks, not due to software, but due to electronics fault issues and hardware problems. So as my understanding from talking to different people at NASA is that program's over, and they are looking to launch a new version in the future, though. One thing that, as we talk to more and more people in the industry, a common theme that's really a big topic right now is on-orbit satellites, servicing, assembly, and manufacturing. The idea that you can upgrade or repair satellite assets that are in space rather than just having to decommission them and launch another one. And this even has implications for deorbiting satellites if you can grapple them and then change their orbit or refuel them, recharge them, reducing space junk and debris that's happening. And then NASA and a number of other space organizations, ESA, they're all working together to get man and woman again on the moon. And that's this decade, in the next few years, they want to start having humans and robotic assets back on the moon. And this is all, of course, a staging ground for future aspirations to go to Mars. And so how did PickNik get involved in all this? Our director of research, Dr. Mark Mull, had a relationship working with NASA in Houston for a long time. And so when he joined us, we put together a proposal to work on with a small business innovation research grant, which is a program in the US for doing research. We're now in our phase 2 of that. We did win it. The topic being advanced planning capabilities for robots in microgravity environments. So this has been a really amazing experience for us to talk to a lot of people at different NASA centers, as well as a few groups in Germany and other, like Canada, the different groups that have robotics. There's a lot of existing systems there, but we were surprised to find how many of those research teams were already actually using MoveIt. And so the question is, like, how much of MoveIt, how much of ROS, how much of ROS-2 can you actually use in space versus just for prototyping on Earth? And there's a lot of different levels that have been used for that. So our research under this funding grant has been around supervised autonomy. And so we are fast at work right now launching a new product that allows for a level of human in the loop. And it's interesting that, I am talking to an industrial conference right now, and typically when all you care about is cycle time, human in the loops is like the last thing you want. There's not a good ROI when you're trying to augment humans in a factory floor in a logistics warehouse, but rather you want it just to like stamp out widgets as fast as possible. But there are a lot of applications, a lot more of the traditional ones we've thought of with robot arms, like bomb disposal or nuclear disaster recovery, and also space robotics, underwater robotics. And I hope that there's a whole new slew of problems like this coming up. Like if we want robots outside of factories in our everyday lives, we are going to need really a way for robots to get help when they get stuck, because they're such unstructured environments. And that's really where these technologies come to play of how can a human be in the loop but not be doing teleoperation? Teleoperation being like a one-to-one mapping. I have a joystick, I have a game controller, and I'm just controlling the robot in Cartesian space or God forbid joint space, which a lot of companies still do, surprisingly. And we say, no, let's make the robot as autonomous as possible, and only provide very high level input for humans, saying like, hey, move this object over there. So we have these tools in MoveIt largely built already and in the ROS ecosystem. And so now we're leveraging that to find the best combination of the user experience, the UX, the UI, and the technologies of AI and motion planning. We think this is an industry trend that's going to continue. We see this in the self-driving car industry, actually. They've been promising us our self-driving cars for many years, and they keep falling behind on their promises to us having them in our streets everyday lives. And it's because actually AI is really hard, and there's really fundamental limitations about the general understanding that robots have today of their environment. What we say is understanding really is still just complex math equations that they're running through and statistical analysis that's happening. So The self-driving car industry has also had to fall back on these call centers of humans in remote operating centers that are able to jump into a fleet of cars and provide extra assistance when something unknown happens, like a construction cone got moved or some road's been changed. And so it's a little more about MoveIt Studio. These are some of the concepts where we can define these missions, which are multi-step objectives with a lot of tasks and subtasks. And so we're using tools in MoveIt like the MoveIt Task Constructor, which we've been developing the past few years with various collaborators, particularly in Germany, actually. And they and so this tool just will allow you to, like in simulation, define all the steps that you want the robot to do on a daily basis. So like today's task order is we're going to move some cargo bags over here. We're going to do some repairs on this equipment. And the next day, those jobs could all change. So it's not like you can program it once and just expect the robot to repeatedly make that thing every day. So what are the right combinations of flexibility and power where the robot isn't relying on you to control it one-to-one in that teleop way? And so this is, we want to make the human more as a supervisor who is monitoring it, only jumping in when necessary. That could enable a really positive fan out where you have one human operator to multiple robots, maybe 10, maybe 100. So that's kind of the meat of what we're building right now. And so I just wanted to talk more about the history of ROS in space and some of the challenges that we're learning about as we are talking to tons of companies in the space industry about using MoveIt and MoveIt Studio, about using ROS-II. There's a lot of positive progress, but it's not as easy as it sounds. There's going to be a lot of challenges in this process. So as I started to assemble robots that have been designed for space and for ROS, I was actually quite surprised that I found all 5 of these. We've been talking to these companies, and this is really positive that ROS, I think these are all ROS 1.0, but they've all found a lot of use in developing on Earth, and even some of them using their controls in space. Of these robots mentioned here, only the Robonaut 2 and the S1 Gatai actually has flight heritage at this point. Flight heritage meaning they've actually been to space. However, the Motive Space Systems robot, X-Link, that's the same company that did the Mars Perseverance rover. So they built arms for space. They have a lot of talent from JPL. So even though this particular arm I don't believe has flown yet, it is built for that. So these are all examples of how much ROS is coming to space and has been found value. And beyond that, like another robot that isn't an arm is the Free Flyer. I'm sure most of you've maybe seen videos or pictures of this. They now have a couple of these Astro Bees floating around the space station, providing extra situational awareness to ground where it can just fly around wherever, take sensor measurements, monitor things. And they are actually using ROS internally on this device in space. Talking to people in the industry who are really familiar with the software, ROS isn't quite flight certifiable in terms of what a Class A mission would require, where it's controlling the rockets on a human flight, where safety is so critical because any misstep could result in another disaster. But they consider the Astro Bee an experiment that they can isolate on the station because it's not actually plugged into anything. It's not connected to the ISS life support systems or thrust control. It's really an independent object. I mean, yes, it charges, but my understanding is that because it's so isolated, they've been able to use ROS a lot internally, and that's actually enabled a lot of different research collaborations for that group to upload software, different university teams using the standardization middleware. That's, I think, a huge success story for ROS. And of course, they're also using ROS for ground control for their simulations, their software, so that they can evaluate stuff without actually connecting to hardware. And then an upcoming program that Open Robotics has announced in collaboration with NASA is the Viper program. And they're sending a rover to the South Pole to search for water, among other scientific missions attached to it. So this is all, I have a bad picture. Ignore this Astro Bee here, but the exciting thing here is that they are using ROS-II on this, not ROS-I, but ROS-II, and this we should see launching in about 2 years from now, late 2023. So this is showing that all the work that Open Robotics and the ROS communities put into ROS-II hardening, I think, is paying off. They've listened to their community in a lot of ways, especially with DDS, which is something that NASA already was using for a lot of different areas. And so I'm excited to see this coming up. But I keep mentioning the challenges. So we are gearing up to write more spaceflight hardened software. And so our teams are really learning about the code quality requirements. And sometimes they are counter to open source communication. Like open source, anyone can go to GitHub and submit some fixes, and ideally someone responds and merges the code in, and everything's happy. In spaceflight hardware, there is more rigor required, where the bar to contribute is going to be higher due to traceability requirements and verification validation. So you need to, if you're going to be considered spaceflight hardened, you have to write a bunch of requirements documents and do both verification and validation to make sure that what you've built meets those requirements and does its intended purpose. So this requires traceability, this requires fault containment, and in general, like there's a lot more, the space industry is a lot more conservative in the type of technologies they adopt. So, I've just shown that there's a lot of positive progress in adopting ROS, but there's also still a lot of skepticism about it compared to how the big government contracting firms and researchers have been doing it in the past. So Terry Fong is a director of robotics at NASA Ames, I believe, and he's had a lot of thought pieces about how ROS can and can't be used in space. He claims that good software architecture is the most important defense against incidental complexity. And so making sure that, the challenge to us as a ROS community is making sure that we are actually really putting a lot of effort into thinking about architecture and quality. In 2013, he actually published a paper, he gave a couple presentations where he claimed that ROS was actually not suitable for flight systems and only was for prototype work, although he claims space station testing, like the Astrobee program inside the space station, those are okay, but for something more critical, ROS would not be that. I think this is a little outdated now, because talking to lots of people at NASA Johnson Space Center, for example, there is a lot of optimism that we can actually certify ROS in space. Some of the challenges that frequently come up when people talk about this, radiation hardening requires that the electronics you use be a lot more pared down traditionally, and so you don't have as much processor power. You don't have like maybe the type of kernel that we're used to with like an i9 or i7 Intel chip. The swinging temperatures really affects the type of electronics you're using, and even power requirements of, like, you have these solar cells and they have to be prioritized not just for your robotics hardware, but for all the other support systems going on, the telemetry, the thrusters. So these are the challenges that we're facing. However, at the most recent ROS World, there was a great keynote by Kim about how there's this collaboration now with people at NASA and Blue Origin. And so they've now announced the preliminary working of Space ROS. It's definitely not done. I think my understanding is it's in infant stages of being developed, but it's the, quote, space community software framework for advanced robotic systems. And so the effort is just starting to mature. ROS-II, it will be open sourced. Unclear if it will be a fork of ROS-II or if they can keep it as just these particular repositories are for space use, and these have not been certified. But Will Chambers at Blue Origin is doing a great job on leading that effort with a bunch of different NASA groups. Part of that is just complying with a lot of different standards and collecting the right artifacts that indicate you've done the right things to build continuous integration and continuous qualification. One interesting tension, I'd say, or dynamic in part of this Space ROS effort is that there already is a standard that's been developed by NASA that is open source called CFS. And so we've been digging a lot into understanding how core flight software could interact with ROS. They've been built for fairly different use cases. CFS tends to be very satellite vehicle focused, where all sensor data is considered telemetry that gets piped back to Earth, and all commands are basically, like, everything you publish to a pub subsystem are basically commands coming from Houston or from whatever your space command is, and not really thinking about like different nodes and sensors talking to each other in space, like ROS typically, you know, onboard robots talking to itself a lot. So there's a lot of similarities, a lot of differences, and there have been 3 efforts that I know of to create ROS bridges between CFS and ROS, where the communication gets translated. And so TrackLabs, Honeybee, and JAXA in Japan, they all have different implementations of this. My understanding is that they're not super robust, and there's the question of like, should this even be tried? There's also efforts to possibly remove DDS from ROS2 and maybe have CFS be the underlying message passing. So there's a lot of open questions right now in the industry about how to rectify this standard that the gateway is being built, which is the new station that will be orbiting the moon, as well as a lot of other future assets. Another thing that about CFS is that unlike ROS community, it's a lot more segmented, and there's a lot more fork and develop on your own, and not as much package management, community sharing, standardization. And so that's some of the challenges ahead for the CFS groups. And I have to, this is a lot more hypothetical, but we've got a lot of interest for a space MoveIt. Maybe this is going to be MoveIt 3.0, but it's an effort to build a MoveIt that works for space ROS and has similar qualification requirements. And we're really excited about this because it's an opportunity to standardize for all the companies I presented earlier that are building robot arms to have a common interface that allows for space missions to be assembled a lot faster, because you're not having to build all the software from scratch, but really emphasizing reusability for motion control for robot arms. And so we're in talks with a number of groups on this with NASA, and the preliminary efforts will be around just improving code quality. We already have a lot of CI linters and auto formatters, Clang format, those sort of things, but even better improving the way we're doing threading and memory allocation to be more space qualifiable. You can't throw exceptions as an example of things that have to change. And I just want to tie this back to the business cases, because I understand today, again, is supposed to be more about the commercialization of this. So how does this tie to ROS Industrial? Like where's the funding come from this? Typically, when we think about space programs, we think about kind of R&D, basic science, exploring the frontiers, and we don't think about manufacturing. But there's been a lot of VC funding and huge valuations of money being raised for the ideal of doing like shipping raw materials to space, to low Earth orbit and beyond, and actually doing additive manufacturing in space. So basically building factories that float above us. And there's the desire to build bigger spaceships, bigger satellite infrastructure doing this. And that has its own purpose because it's easier than launching it all in like compact systems. But beyond that, there's also the possibility that we can build better products for Earth in this near zero gravity environment. And so the examples that we always hear when talking to companies in this space is you can get better fiber, with much fewer defects, way better transmission data rates. Bioprinting, I'm not a biologist, but my understanding is that you can like grow organs or different things that on Earth have a hard time being grown from a petri dish because of the gravity, and requires a lot more complexity. And finally, you can get different medicines that we can't make on Earth. And so there's a lot of promise here, and there's groups that are starting to build these out. The big challenge continues to be the cost of launching these things and getting them back to Earth. Is it really cost productive to do these things? SpaceX has had a huge impact on changing the economics of launch systems. And I think Blue Origin's, giant rockets they're developing will also do that, or are also doing that. But it's still not the cost of like, a giant freighter ship across the ocean. Those costs are crazy low. And just a few more pieces of data. This report on the business case for space is saying that there's been just a huge amount of activity in this sector in the past few years. The goals that are being set are more and more audacious. It seems like there's a boom right now. Hopefully there won't be a subsequent winter coming up where people wake up and realize that it's still not quite feasible. But right now there's a lot of investor energy and excitement in this sector. The picture here is the recently announced Orbital Reef, which is one of the space stations being proposed to replace the International Space Station, which is now end of life. And finally, a few more stats. currently the size of this is $350 billion market, and they're expecting by 2040 this to be a 1.1 trillion. So a huge growth there in the space industry, global revenue, and a few other things. NASA has a $21 billion budget for this moon program, and they're increasing that further. Jeff Bezos has pledged that he's willing to sell $1 billion of Amazon stock per year to fund Blue Origin, which is crazy that he can just do that. Really emphasizes the amount of money here. It's crazy. And similarly, SpaceX keeps raising tons of money to develop their programs. So with that, I will kind of give my summary. PickNik has been building applications for lots of different companies on Earth. We'll continue to do that. We leverage ROS-2, MoveIt, but most recently we've had a lot of interest in space applications, and so we've been diving into that as well. We intend to continue supporting both. Space can be very boom and bust. It's a kind of a difficult economy. If, for example, in the U.S., Washington, D.C. decides to have a change of heart about their investment, that can really change. Like every president we have here really messes the economy up there. So we are cautiously optimistic about this industry. I hope I've motivated in this deck how ROS-2 is making a big impact in the space applications, but also the challenges for flight certification. In some cases, you don't need flight certification, but in many cases you do. And so the big announcement from ROS World recently was Space ROS, and PickNik's excited to be involved in that. And just in general, I think the space industry is something to keep an eye out for, because it's growing very rapidly and actually has manufacturing. So maybe we'll have a ROS Industrial space in the future. For more info, check out our MoveIt website. And yeah, thank you.